All right. So we're doing these, yes. Who still needs 824? You don't have it. You can't find it. You lost it. I will print you another. Yes. Scientific notation. Yes. It's an AB conversation. Anybody else? Need 824 because we are doing questions on that worksheet. All right. Who? Actually, no. Let's go random card. Ike, can you remind us why we use scientific notation? You can, you think. I think you can too. I believe in you, Ike. Are you going to give it to us or just keep it to yourself? You won't share with us? I'll take that as a pass. Xander?
Oh, I don't know.
Maybe because you looked in my deck of cards.
What's my vision is not good. We use scientific notation because sometimes numbers get too big to just use like normal numbers.
Yeah, like 35 wouldn't really need to be written in scientific notation. But 35, I don't know, trillion might appreciate being written in a bit of a smaller format. Or, like 35, I won't even get this right if I guess, but like, 100 millions, or like really, really, really small, right? So we use scientific notation when we're trying to rewrite. I'm not trying to get it right. I probably said that wrong, right? So we are going to rewrite this using not the whole number, and actually right now we will just go ahead and get rid of this one. We will talk about the giant number we have up here. 35, what? This would be billions, right? So this is trillions. Yeah, I got this one right. So we have 35 trillion. Go ahead and write this number on your paper real quick. Like on your graph paper. We're not on your purple paper yet. One-eyed, one-horn, flying, purple people eating. You've never heard of the one-eyed, one-horn, flying, purple people eating? Now, moving on from Xander, Serena, what is the rule about that? So we're going to write this in scientific notation. But what's the rule about this first number that then we're going to have times 10 to them? We talked about how for some reason we often use the x here. It's not the variable x, and you can use the dot, but I'm writing it like this so that you guys have had exposure of seeing it with the x being used. So we pretty much haven't used the x to multiply at all this year. But Serena, do you remember the strict kind of rule about the number we put here? And less than... Yeah, it has to be between 1 and 10. So here, we're going to write this 3.5. Go ahead and write that on your paper. And then Alex, Sheeta, how do we figure out what power goes up here?
Well, the easy way is just to count the zeros.
Easy way. If I count the zeros, 3, 6, 9, 12, so a 12 goes up there?
Oh, wait, no. And then you count the numbers. You count how many times you have to move the decimal point.
This is where people trip up, and I need you to hear me, because if I ask you to write a written response about this, you need to be able to actually say it, right? How we determine our power is how many spaces or places the decimal needs to move to get back to the original location. So if this is the original number, that's the original location of the decimal. We have given a new home to the decimal right between our two numbers like we want. So we need to move it back 13 places to get back to here, meaning this would become 10 to the 13th.
Move up back. We need to move right.
Well, forwards, yeah, I guess you would, depending on what. I was moving backwards and undoing what we did, but yeah, you're right. We're not really moving back. We're kind of moving forward. Questions, confusion, comments, concerns?
And when it's a decimal, then the exponent is negative, right?
When it's a tiny number, yes, we will get to that. Because this is technically a decimal number. So be careful with saying like
Below 0.
yes, when it's a small decimal number, a fractional decimal number, yes.
Okay, so what's the first problem we should write down on our graph paper?
Well, I mean, this, I kind of just asked you to write this down, but that's okay if you didn't. We're going to move on and do some on the purple paper together.
Ooh, that's a
Or
big
it.
whale.
Time.
Technically, wouldn't it be an improper fraction, the number that we wrote? So it would still be a fraction, so it would have to be a proper
Does
fraction.
that decimal, or does that number use a decimal?
Yes,
It's a decimal number.
and also a fraction.
Sure, you could write it as a fraction. I mean, like a fractional quantity, a partial quantity, less than 1. You know what I mean? Let me give you one social filter. When your sentence has to start with technically, ask, is it necessary? Right? Like, because I agree, what you said is right, but we just spent 30 seconds that we could have just gone ahead and talked about our dwarf whale. So, the dwarf whale compared to, blue whale, my bad, dwarf whale compared to the blue whale. So the dwarf sperm whale is the planet's smallest whale species, but even though it's the smallest whale species, it weighs 3 times 10 to the second pounds. A blue whale, a lot more than that, weighs 4.5 times 10 to the fifth. Estimate how many times heavier the blue whale is compared to the dwarf whale. Work with each other. I'm going to say probably 2 minutes, maybe. Doubt you even need that long. But grab a calculator if you need. How are we going to compare these two? Your number should be greater than 1 because we're comparing the blue whale to the dwarf whale, right? So we're talking about a ratio, blue compared to dwarf. I don't want an answer right now. I want you working with each other. Did you hear me when I said that?
Yeah.
When I said, like, I don't know, maybe 2 minutes?
Maybe.
Oh, crap, I wrote that in the wrong place.
300 now.
And then, can you figure out the shortcut? Can you figure out the actual, like, trick we could apply to solving any problem like this?
What's your always in trick?
Not really trick. I mean, we say trick, but it isn't really trick in the bad sense of the word.
I don't know, but there's always some like shortcut to figure something out.
There's always shortcuts.
So there's the true, let me understand the math and do all of the math. And then there's like, oh, I could punch it in a calculator and get the, you know what I mean? That's like the trick, is use a calculator. The trick is,
Mom, you can always do that with something.
it depends. Not yet.
Getting my calculator. I know he's gonna take away my secret stash. Whatever those things are, if I get them out. I'll bring in even more.
If we can't figure this out on our own, we could take them back to standard form and compare those numbers with each other. Because we know that if we write 4.5 times 10 to the fifth in standard form, we'll just move that decimal over, and this would become, well, that's 1 spot, 2 spot, 3, 4, and 5 spots. 1 spot, 2 spot. So really, we have like 450,000, which, guys, remember, real information here. And that's where Simon was like, wait, this has to be wrong. Simon, what did you first think 3 times 10 to the second was?
But also, this picture is incredibly inaccurate.
Well, you are correct. It's hard to make accurate pictures of things like this.
Also, what does a blue dwarf whale really look like?
It's not blue dwarf. It's dwarf sperm, and then so sperm whale is its own type of whale. Okay, immature eighth or immature seventh graders, get it out. So sperm whale is a type of whale. Dwarf is a species that is part of that. So like there's even dwarf plants, right? Dwarf is a type of species. So it's the smaller version. Blue whale is just a blue whale.
There are dwarf.
And actually, I think some of them are called great blue whales.
Oh,
So Simon, hey, up here. Simon, talk to me first. Hey, stop. I don't know who keeps I gotta start my conversation back up, but Simon's trying to talk us through this.
You can reduce two of the zeros at the end of the 300.
I like that you said reduce also.
And then you just divide 450 by 3.
Okay.
4,500 by 3.
Okay.
Which is 1,500.
So we get 1,500. Which, if I'm trying to work in scientific notation, that's like 1.5 times 10 to the, if I put that there. Can anyone spot a shortcut? Charlie?
So you subtract the two numbers that are going to be multiplied by the 10, and you subtract the top exponent from the bottom exponent to get that. Get to there.
Now be careful.
It's not.
This is not the result of subtraction.
It's the result.
Go ahead.
It's the difference.
No, difference is subtraction.
But not like.
You're using the wrong word.
Addition.
No,
Like.
it's the quotient.
Oh.
This, guys, you might need to write this down because this is true. And I dislike this problem because you can subtract and get that number. I'm upset that they chose these numbers. This is the result of division. So we quotient. We do the division, and we get the first number. And guys, this is actually also the quotient. This is the result from dividing.
Oh yeah, because you can.
But what we can do with the powers, our trick with the powers, is to do the division with the powers. We subtract.
I was like, wait.
Sorry, do you have anything? Do I need to turn it down?
No.
Oh, you look like you feel rough. Are you feeling sick? Do you need to go to the office? Are you
Yes.
sure?
Lying. I don't want us to be sick. Leave now. Go.
Hey, no. We're not going to make you feel worse. But genuinely, like if you feel like you need to go, just get up and go. Okay? So guys, this is the trick. Now hold up. This only works if this number is bigger than this number. Because otherwise, this won't be in the right form, but we'll play with how to fix those
Because
situations.
it'll be less.
So I think this is graph paper. Or no, this is still, the next two are on your purple paper.
Okay.
What do you think? Oh, sorry, we need to do A first. So, how many molecules, of sugar does the baker use? So there are about 1.8 times 10 to the 22nd molecules. Grab a calculator if you have one close to you. If not, it's okay. Excuse me. And 1 gram of table sugar, which if you wanted to see what sugar is scientifically, I'm not sure. Probably whatever bakers use, which is probably the
Well, I
sucrose.
know what it is.
A baker uses 8 times 10 to the second grams in their recipe for cinnamon pastry. So we know based off the last one, that's like 800, right? I mean, in times 10 to the 2. So that's like 800 grams of sugar. I don't know. Yeah, it depends on how big that batch is, right? That sounds like a lot, but I don't know. So how many molecules of sugar does a baker use? In your calculator, there's actually a way to do scientific notation. Like a really nice way. Which actually, I'd like you all to have a calculator. So if you don't have one, pick some of those back, will you? On the 83s, you're going to have to find it on your own. It is a button in there. It might be hidden in the menu. But on the 30s, here, at least everyone who's here to compare. On the 30s, give me your eyes. Give me your eyes. Give me your eyes. Give me your eyes. In the middle. Times 10 to the n. Anytime your calculator says to the n, it means they're going to ask you what to type, like what to put in. So when you hit this button, it's going to plug in the times and the 10, and then it's going to give you a little blinky box where you type your power.
It says answer times 10.
Oh, that's because you went ahead, you didn't type a number first. So thank you, Liam, who did this on purpose, right? You have to first type the first number. So to type this in your calculator, you need to type 1.8, then hit that button. Then make the power 21. Then bump to the right, like hit the right arrow to get out of your power. Then hit times and type in 8. Hit the scientific notation button again and make the power 2. Or you could just multiply by 800 because that's probably just as easy.
Oh, Mr. House.
And your answer is either that or it put times 10 to that and it actually gave you the power. But some of you, depending on the setting of your calculator, are going to get this. Math print versus classic print, right? It depends on what setting you have your calculator in.
What's that?
E,
Hit mode. It's 10. Hit mode. Right?
close.
It takes you to the
E, and guys, this is like computers will spit this out. Like, you need to know this. E represents exponent of 10. So you might want to write that out. E means exponent of 10. There's another reason why your calculator does that. Think about your calculator as a confined, limited screen space. Which takes up more space? E or times 10 to like x10. E is smaller, right? It's less of your screen. It's only one digit as opposed to 3 times 10, right? Times 10. That's 3 parts of your screen. E is easier. Not to make that joke, but like that's why we do it.
I once tried to do, I once tried to do 60 to the 60th power, but that didn't work because I didn't have the E mode on. I don't know if it would work with the E mode on.
So let's talk about why we use our calculator. Look at 102. It's on your paper. If you type in just 6.01 times 1.75, what do you get? Just type it without the powers, without the scientific notation. What's 6.01 times 1.75?
10.5175.
Is that going to be in proper scientific notation form? No. So hey, give me your eyes up here. Hands off calculator for a minute. If I think this through separately, like I do the math on my own, I don't use the calculator like the nice way of doing it. I could just add the powers, 20 and 14 times 10 to the 34. I could do this. I could do the multiplication, get the green number. I could add the powers, get my blue number. However, this is wrong. So I would have to fix it. I have to move this over, which moves this up. And instead of wasting all that effort, I could just type this all in my calculator. Right? So if you type in 1.75, that button, to the 20th, times 6.01, that button, 14, you'll get the proper form of the answer, 1.05175 times 10 to the 35th.
Or just add the exponents together.
When you forget to click the right arrow.
But that doesn't actually get me to the right exponent. Right? That's what I'm trying to get you to realize.
Well, it does, but then, well, kind of. It's above 10, so then it reduces, well, not reduces, then it moves the decimal points, so then it opposite, yeah. But it's,
You're saying everything I just said.
but it works like that.
What you're saying is not wrong. Hear me when I say what you're saying is correct. What I'm teaching you is the why. Why do we have these tricks, these methods that we use? Because I can do it separately. I can multiply the bases, 1.75 and 6.01. I can multiply the exponent values, and then I can fix it. Or if I'm gonna use a calculator anyways, because I can't in my head do 6.01 times 1.75. If I'm gonna use a calculator anyways, just use it for the whole thing. Use the buttons that have been designed to make your life easier. Let your calculator do the tough stuff, right?
Wow.
You're here for the thing that the computer can't think through because you have a brain. Let the calculator carry out the computations.
How do calculators work?
They just carry out the computations. We train them,
They also
and they do what we have told them to do.
Like a dog trainer? Like how do they
No. It's like a
program? But they don't always feel
Why
like
are you in lotteries? You don't know what you're doing. You don't understand what you're doing. You're wasting your time, Hazel. I'm not saying that, but is that what we're doing right now? No. So,
I mean,
I'm never going to tell you not to play with math, but that is not what we're doing. On your graph paper, please.
Wait, what's
If I wanted to make a paperclip chain and lasso the sun,
Wow.
Excuse me?
Well, these paper cups have to be like
you know I have feelings, right? I might be a teacher, but you know I have feelings.
Yes.
Because Liam just real quickly said, what a stupid idea.
He hears people on the
Okay,
phone.
Mr. Hudson.
The distance that I'm about to throw Liam from here to the sun is 1.488 times 10 to the 11th meters. I could probably get you a little bit of the way there.
Wow.
The length of the average paperclip, because it's not more than a meter, is in small number scientific notation form, right? Negative power makes you have the tiny numbers. So, because remember, that means divide by 10 twice, right? So 3 divided by 10 twice. So if we wanted to say how many paperclips it takes to get to the sun, ignoring the slight overlap of the lengths, we've already compensated for that. This has already compensated for the overlap. Got you there.
Wow.
How many paperclips?
A lot.
All right, first one to get the answer. I don't know. Gets a piece of candy.
Oh, what? Don't answer it. I already have an extra one. Because Mr. Hudson keeps just pulling them out the bag.
427.
Why?
No answer is stupid.
Oh, yeah, because I was thinking we would know.
I got
to
six
figure
out
out
there.
how many.
Pretty sure
Is it the right answer?
There. Give me scientific notation.
No!
I'll just fix it.
4.464 to the
Times 10 to the, but yeah,
times 10 to the 9.
to the 9. Do we agree, Henry? Do we agree with
I
that?
got 4.96 times 10 to the 11th.
Ooh, we have a discrepancy.
You divide. No.
Let's.
It's possible that I put too many zeros in this number. Yeah, I think that must have been it.
In which number? Oh, wait, did you not work in scientific notation?
No.
Oh, you changed your numbers first. If we changed our number, well, if we at least changed one of them first, right? Like the denominator down here. If 3 has its decimal here, and we're told times 10 to the negative second, what's this actually representing? 300ths. It's actually not that small. That's like, it's small, but it's not that small. Because this would be to the negative first, and the negative second just has to bring in 1 extra 0. So if you tried to type this in manually, your denominator should just be 0.03, 300ths. Now, did you type this in scientific notation, or did you try to type it in manually?
I typed it in manually.
Ah.
I may have gotten too many or too few zeros.
this is really close to 1.5, right? I'm going to do some approximate math for just a second. If that was 1.5 over 3, it's like a half, right? Approximately, just stick with me. Well, squiggly equals. What would I do with these powers?
No, then you changed it, so it's not right. It would be 1.5.
Oh no, you subtract.
Yeah, it would be 13.
You subtract the because it's still division, and then you do
You know the fun thing about words? You can't put them back in. Sassafras.
That's like toothpaste. I have the
I love how I didn't have to say anything. Alina argued with me, but she really argued with herself because I just stood up here doing this, and then she realized, oh wait, no you don't. But there's no I'm sorry or anything else. It's just, oh.
I'm sorry, Mr. Hudson.
So what do we do, Alina?
We subtract.
We subtract. Now wait, I'm going to rescue you. I'm going to dig you. Why might you be saying add here?
Because it's subtracting a negative, so you would do 11 plus 2.
So we subtract in division, but because it's minus -2, this would actually be 13. But this isn't in the right form. Right, we gotta fix it. I'm coming to you in just a second, Patrick. So, remember, we're still working in approximate math, but if I bump that to the right, do we remember what happens to our power?
It goes down.
Goes down. This is why we're practicing this. So this, oh crap.
Should it be 1.5?
Yeah.
No.
1.5 over 3, which is a half. Math teachers don't make mistakes.
Oh, yeah, we do.
One time when they say 375 instead of 475.
If we're working with approximate math, and we say that this is 1.5, and this is 3, 1.5 compared to 3 is a half. Not 1 and a half. It's a half, right? 1.5 compared to 3. That reduces to a half. Now we know it's technically 4 point. Was this 964 or 464?
496.
This is 9.
My calculation.
No, it's 4. It's no, it's
I
4.
said
It's
496.
4.344. No, it's 4.344.
Mr. Hudson.
It's
I don't get
4.344.
Okay, we have at least 3 different answers. We need to find out which one's correct.
There, that doesn't mean you're right. You could have made a
I
mistake.
just heard like 7 different answers.
Hey guys, if you have any more decimals, you did something weird in your calculator. Unless this one is in a weird setting, let me double check. Yeah, it's 496. So this, what's really close to a half, is really 0.496, is really times 10 to the 12. If you can't get that, guys, I'm serious. Like, I'm being 100% serious here. If you can't get that, you need to practice typing in your calculator. I'm not joking. Like, some of you work too fast and you don't pay attention to the numbers you're typing. That's exactly what you should have. 0.496. But, sorry, crap, I wrote this in the wrong form now. It should be 4.96 because we fixed it. We already fixed the form. But when we do the division, we got 0 point,
That is really
and then we had to fix it.
Wait,
Yes.
why did you get 4.464?
That was a typo. It was supposed to be 964, but I heard him wrong, and then I wrote it. And that's, I did put a question mark here saying, wait, is this actually it? Because this was actually wrong, too. This was not right. So here's where you got to be listening, and it's hard when there's side conversations going on. This was what a classmate proposed was the answer, and I said, are we sure? Let's check. And then we went through the process and broke it up, did it, and came back and said, oh, that's what it actually is.
But I suggested originally.
I did multiplication. I forgot.
Who gets the candy?
The SAS meter's going up.
Not sure. That was tough with two.
I think it was mine because I said the correct one first.
But did Bear say it correctly, but he misheard it?
I'm not sure Bear has to tell us that.
No, Mr. Hudson.
Okay, either nobody gets
Bear
candy, we all
said
get candy.
6, like 4, like 6, 4, 6. And then Henry said, no, I think Heather Bear.
Aren't chocolates poisonous to bears?
Yes. Bears even say that Henry.
Here, let's reset. We'll go candy for this problem then, since the last one fell apart. Jupiter's far. Maybe to us, but we're talking from the sun. This is not on your orchid paper. You are doing this either in your calculator, if you trust yourself, or you can write things down.
I haven't trusted myself in a long time, Mr. Hudson.
You have to be able to tell me the mathematical justification.
Oh, dang it.
That couldn't have been surprising.
Oh, dang it.
Oh, no. What?
I give up.
I love explaining. Wait, if you answer first, Mr. Hudson, do you get candy?
Well, you already
No,
answered.
it's-
You unlimited candy.
I mean, I'm doing it with you, actually. Now, the fun thing about scientific notation is it's just a guide. You don't have to work with exactly the numbers that they told us. Bear's got his hand up again. But as we said, chocolate's dangerous for bears. So.
It's a good thing. You like that?
Have an answer?
Yes, it's distance to Jupiter is less.
Do you know by how? Do you have subtraction less or a multiplication sort of like less?
I can do subtraction less.
Do you want to tell us the difference in the distances?
Oh, wait, I think I'm right.
Mary, do you think it's less?
Yeah. By a lot.
By a lot. Okay, if we first think about the combined distance here, I need somebody to give me that. What is the combined Alex distance here?
Wait, can I see like my full answer?
No, because actually I'm going back to Hazel because she was the first one.
Well, the combined is 3.597 times 10 to the 8 up.
Now, funny enough, I actually got a different answer.
Yeah, it's not right.
I got. You're being a jerk today, man.
Sorry, I didn't mean it like that.
Uh-huh.
No, I'm serious. I'm
Continue.
serious. Continue. He was?
Is. So, but I got this. I got something different than Alex. Avi, can you explain what is going? Audrey, can you explain what is going on?
Your answer is not in correct scientific notation because you can't have a double-digit number in the first place in front of the decimals.
Do you know how I ended up with that? So is my answer wrong, or is it just not in the right form?
It's not in the right form.
But it's not wrong.
Maybe.
Do you know how I got this?
Nope.
Alex, do you know how you got yours?
How I got mine?
Yeah.
Oh, I
Or did you actually like type them into your calculator all individually?
no, I did it like all in the same equation.
What do you mean?
Like I typed it all.
Like, did you type times 10 to the and then times 10 to the like for each of them?
Well, like I did. What I did was I did like one equation plus the next equation plus the next. But
Man, did anyone not use the times 10 button? I didn't. Did you not use the times 10 button?
Mine doesn't have a times 10.
Ooh, so what'd you do instead? Oh, you just had to type it out. Yeah, that was even harder. So Bianca's absolutely right. If you have one of these, and actually I'll show you later, you do have that button. It's just hidden in a menu. Come to me after class, or actually maybe just a couple minutes. I can show you where that button
Wait,
is. You have that button.
can I
It's
guess
just a
what
different
you did?
calculator.
Can I
Sure.
Did you add the decimals, then add the exponents together to like make one?
I didn't add the exponents.
Or did you?
Think for a minute. Everyone just take a beat. Take a beat. How did I, because if we were really in a race, I totally would have beat you. How did I not use times 10 on my calculator? I just speak in facts. I'm not like trying to throw shade. I'm just saying. Simon?
Yes. So you just added all of the things that are being multiplied. I forget what they're called. But you added the things that are being multiplied by the 10 to a specific x. Well, you added them. Sorry. You added those things, and then you just multiplied them by 10 to the 7th since they.
You're really close, but I think if I go and I check the addition of these numbers, I don't think it's 35. Because I have like 5, 6, 9, and 1.
Almost 1.5.
There's something I did first.
I would reduce the exponents.
You what?
Divide them all by 7. I mean, 10 to the power of 7.
I mean, if you did that, I'm trying to go down this road.
Not divide by 10 to the power of 7.
I like what you're saying. So Logan is essentially saying,
Basically divide by 10 7 times.
and that leaves this number not being 1.4, but being 14. What Logan just said is get rid of these times 10 to the 7th by dividing each of them by 10 to the 7th. We know that later we can bring it back, but make it easier for now. Here's the real rule I'm getting at. So if you glazed over and stopped paying attention, come back to me now.
This is basically an equation.
So listen, we can ignore, just listen for a second. We can ignore the scientific notation momentarily and just work with the numbers if all of their powers match. And this one doesn't. And if they don't, we make it so. Number 1. So this is 14 times 10 to the 6. Or 7, sorry, 14.16 times 10 to the 7. Because if I want to reduce this number, this power, all I got to do is move this decimal by 1. So, yes, I did just 10 minutes ago teach you how to use this and the times 10 button. You don't need that. If your values have the same power of 10, just work with the values and then put that same power of 10 on. Actually, Hazel probably Bear. So Hazel, did you do the subtraction?
Yeah. I think it's 1.23988.
You said which one's smaller?
The distance from Jupiter to the Sun is smaller than the distance from the other planets.
But
I don't think so.
this one looks like it's 3.5 times 10 to the 8th, and this one looks like it's 4.8 times 10 to the 8th.
That's negative though.
Minus, because we were subtracting them, right? We're finding the difference. When, Hazel, here's the trap you fell in. If I compare 35, it looks like this is bigger. But that's in the wrong form. If I put it in the right power, like Alex did for us, and I got it in times 10 to the 8th, this is smaller. Guys, fathom this with me for a second. And most models of the solar system that you see are wrong. Because there's not enough space. When we look at the combined distances, literally, from the Sun to Mercury to Venus to Earth to Mars, and then you talk about from the Sun to Jupiter, that distance is more than the entire combined first 4 planetary distances from the Sun. So literally, if you put your sun in, like, here's my sun, or if we want to, be cheesy, we're going to, here's my son, with he's got sunglasses on and the whole thing, right? Your son always has the sunglasses. We have A. B,
Why does that son
C,
look like Mr. Hudson?
and D, and E.
Wow.
The fifth planetary distance is all of those combined and then some. That's crazy. It's way far away. Most models of the solar system you've seen are wrong. Just because there's not enough space to show on it.
Why does that son look a bit like Mr. Hudson?
Because the natural narcissism of when you draw a picture, you're gonna make it look like yourself. Whatever. All right, I need to go make sure I can take questions for my Math 7 class, and I mean, this is more of the same. So, in questions like this, I will caution you on a couple things before I let you go. Questions like these, their powers don't match to start. So you have to be very cautious. We cannot apply that trick we were just talking about when the powers don't match. Excuse me, so either we make a match or take them back to standard form and work them in standard form, or type the whole thing into your calculator, right? Use the times 10 button, type the whole thing in. Sorry, Patrick, I said I was coming back to you. I don't know if I answered your question or just totally forgot to come back to you. Do you remember what it was?
Yes, I do.
Are you sure? Okay. Same thing here. About how many pounds of each block make up the pyramid. Like, we're working in different powers. So do not compare the 2.4 and the 4.95. So actually, let me show you, like, in a situation like this real quick. If we have a number to a higher power and a number to a lower power, you could write these down if you want to. You want to make me a happy camper? We want to make these match. So we're going to leave this one with the 3 because it's easier that way. And we're going to force this down to a 3. To force it down by 3, I move my decimal to the right by 3. So this becomes 1, 2, 3 spots, boom, times 10 to the third. This is only if I want to compare them using that trick we just talked about. So now we can directly compare these numbers with each other because these match. The easiest thing to do is bring your power down by moving your decimal right.
Finding a common denominator, sort of.
It really is. Yeah, it's finding a common power. Yeah.
1.188 to the power of 10.
Was that division? What'd you do? If each block weighs that much, about how many pounds of... Oh, you multiplied these together, didn't you? So we actually... And I was just giving you an example. For the problem they're actually asking us to do, we don't have to do this. I was just giving you one more example of how we mess with powers. Here, we just need to multiply these together. What could I do to multiply these together without typing in both of those? Fair?
4,940.
Yeah, but there's even easier. I want to multiply these two numbers together, but I don't want to do the times 10. What do you do when you're multiplying with powers, Patrick?
You can, when you're multiplying with powers, you just add them.
You add them. So I can add these together, get 10 to the 9th. We can multiply these numbers and then fix it. Right? I'm going to go ahead and let you guys do practice. You can ask me questions on your practice. So you should be working on 924, or if that's done, work on 824, or 831, or 8 closure. You should have all of those. If you don't, come get it from the binder.
I thought we were out of math time.
No, we are using the whole time, like till the end of the day. So once you get done, yes. So, hey,